Hello everybody, my name is Kristofer Cottingham. I've finished my 4th year of undergraduate physics at the University of Calgary. This summer at the Canadian Light Source, I am working to help automate some of the data analysis at the BioXAS beamline. For fluorescence scans at the beamline, we will have multiple detectors detecting a single signal independently, and some of these measured signals will come back as just a list of zeros, or super noisy, or otherwise just very messy from various experimental errors. So these messy or zero signals need to be sorted out from the group before we do any further analysis. Usually this is done by hand by the user, but to automatically select out the pixels with poor or no signal, I used some statistical methods to reduce each measured signal to this two-dimensional space as shown here, and then I used cluster analysis to find the group of signals that are all most similar to each other. And this pretty effectively sorted out the messy or zero signals, and we're just left with the strong, clean ones here, and they can be used together for some further analysis. However, some of these signals also come out with these very localized errors called glitches, where a single point or a section of the signal will be shifted by some unphysical amount relative to its neighbors. These need to be removed as well for further analysis. The rest of the signal still contains important information, but it's difficult to work with the signal with these glitches in them. So I spent a lot of the summer training a machine learning algorithm to go through and automatically detect and remove these glitches. An example of the final glitch removal process is shown in the plot here. There were many technical challenges throughout the summer, and they were ongoing but very expected. But kind of a cool, unexpected challenge I had was resisting the inertia behind the continuous testing and debugging phase of development. I just needed to pick something and make it work and get it implemented at the beamline. With some help from my supervisor, we were able to get that done. And I learned a lot this summer. I learned a lot about machine learning and X-ray absorption spectroscopy, but I had a kind of cool experience with cluster analysis, where I learned to use it for a project 2 years ago for summer, but it didn't end up really going anywhere. But this summer I was able to intuitively identify it as a possible solution to a problem, and that just really demonstrated to me the value in constantly searching for new experiences and skills. Thank you for listening to my presentation, and I'd also like to thank my supervisor and all the Inspire program coordinators.